This lesson is called Exponent Rules, and there are several rules and several examples in this lesson. The first rule is the product rule, and it is when you multiply two numbers that have the same base, you add their exponents. So our first example, x cubed times x to the 8th, those both have the same base of x. So you add the exponents and you get x to the 11th. If you forget these rules, sometimes you can just write out all the variables or numbers and count them up. So x cubed would be x times x times x, and then x to the 8th, you would have 8 little x's. And if you count all those up, you get x to the 11th. So that's where this is coming from. If you have more than one variable, that's okay. Just the ones that are the same base, you'll add those exponents. So I have an x squared with an x cubed. I add those exponents, and that would be x to the 5th. And then y and y to the 4th. You don't see an exponent on that first y. Remember, there's an invisible 1 there. So it would be y to the 5th when you add the exponents. When your variables have coefficients and you're multiplying, you just multiply the coefficients like normal. 7 times 3 is just 21. And then you add the exponents on the variables. So the w would be w cubed plus w squared would be w to the 5th. And then invisible 1 on the z. So z to the 1st times z squared would be z cubed. The second rule is the quotient rule. So when you're dividing, you subtract exponents, and you would have, when you're dividing with the same base, so for example, x to the 5th over x squared, subtract the exponents, and you would have x cubed. Again, if you forget, you can write out all the little x's, whatever variable you have. And then if you cancel out top and bottom, then what you have left would be 3x's, x cubed. On this next example, we have an x and a y. Remember, invisible 1 right here on that x. So if I subtract the exponents, 2 minus 1 is x to the 1st. 5 minus 3 is y squared. Now look at this next example. If I subtract, 2 minus 5 is negative 3. And that's okay, but generally when we do these problems, we don't leave answers with negative exponents. And I'm going to show you how to deal with negative exponents. But you can take a little shortcut if you think about it this way. So on top, I have 2 x's. On the bottom, I have 5 y's. And I could cancel out the 2 x's from the top. Everything divided out on top. So you're left with a 1. And on the bottom, you have x cubed. So it's still 5 minus 2, but your answer ended up where the bigger one was. The bigger exponent was on the bottom, so the x cubed ended up on the bottom. That will always happen. Back here we had the x to the 5th on the top. So the bigger one was on the top, the x cubed is on the top. So if you can remember, when you're dividing, just subtract big minus small, put the answer where the bigger one was, and you won't have to deal with negative exponents. If you forget, you can always write out all the little x's to figure out where your answer goes. But that's going to save you from dealing with negative exponents with that. Sometimes they can't be avoided, but this time they can. If you have coefficients, you don't subtract those. If you just had 6 over 12 without all those variables, you would just reduce 6 over 12 to 1/2, and you'll still do that. And then the variables, you'll subtract the exponents. So on the x's, 2 minus 1 is 1. The bigger exponent is on the top, so that x to the 1st will go on the top. With the y's, 5 minus 3 is 2. The bigger exponent is on the bottom, so the y squared goes on the bottom. The 1 in front of the x you don't have to write as long as there's the variable there. When we were over here, the second example, we had to write that 1 on the top because we divided everything out. We can't just leave it blank. Okay, the second exponent then, we would reduce 12 over 20. 12 and 20 both divide by 4. So we could reduce that down to 3/5. Then the x's. 2 minus 1 is 1. Bigger one is on the bottom, so x to the first on the bottom. The y's, 5 minus 3 is 2. Bigger one is on the top, so the y squared can go to the top. The 0 exponent rule. So this is a little bit odd. Anything to the 0 power is equal to 1. The variable itself is gone. There are no exponents. It's just 1. So y to the 0 is equal to 1. 256 to the 0 is equal to 1. We have this whole big giant fraction, lots of exponents, but we don't even need to simplify that because the whole thing is to the 0 power, so the whole thing would just be equal to 1. One way to think about why that works is this. Suppose we had x to the 5th over x to the 5th, and we apply the quotient rule, where if you have the same base, you subtract the exponents. So if I subtract the exponents, 5 minus 5 would be x to the 0. And you can also think about it this way. X to the 5th over x to the 5th, anything divided by itself is 1. So the way we even ended up with a 0 exponent is we were dividing something by itself, which is always equal to 1. So anything to the 0 power equals 1. Power rule. When you have an exponent outside of parentheses, it's something raised to a power, you multiply the exponents. So for example, if I have x to the 3rd and it's all squared, I multiply and I get x to the 6th. Again, if you want to think about writing that out, x cubed squared would be if you had 3 x's multiplied and it was squared, which means you're multiplying it times itself, and you end up with 6 x's. For the one on the example on the bottom, 3 squared to the 4th, again, you're going to multiply the exponents, and that would be 3 to the 8th, and I would want you to go ahead and plug that in your calculator to get 3 to the 8th, 6561. Okay, now this is a place where people make mistakes a lot. Be really careful about this one. You are multiplying exponents. You're not multiplying exponents with big numbers, with coefficients. The 3 in front of the x squared has an exponent of 1. So I'm multiplying my exponents, which would make this 3 to the 3rd power x to the 6th power, which is 27x to the 6th. It is not 3 times 3, which is 9, x to the 6th. You never multiply the little number times the big number. You're multiplying exponents times exponents, so 3 times 1, not 3 times 3. So this is no. Watch out for that. That's a real common mistake. It's really easy to do. Your brain sees 3 and the other 3 and multiplies and makes it 9. But it's 3 to the 3rd power, which is 27. Expanded power rule. I just did one of those actually, where you have more than one thing in the parentheses raised to a power. So you multiply the exponents, sort of distribute that out. If it's a fraction, same thing. So like I said a minute ago, for a problem like this, the 2 has an exponent of 1, So does the a. And you're multiplying exponents. You're not doing 3 times 2 is 6. You're doing 3 times 1 is 3. And then same thing on the a. And then 2 cubed is 8. So it's not 6a cubed, it's 8a cubed. You're multiplying exponents. For this next one, the 6 has an invisible 1, so you're multiplying 2 times 1 and 2 times 3. So 6 squared, x to the 6th, and 6 squared is 36. For the next one, multiplying exponents again, 4 times 2 and 4 times 1, x to the 8th, y to the 4th. Exponent on the 2 is a 1 on the x, a 1 on the 3, and we're multiplying exponents. So it would be 2 to the 3rd power, x to the 3rd power, over 3 to the 3rd power, y to the 6th power. And then go ahead and do that 2 cubed is 8. And that's a terrible 3. And 3 cubed is 27. Negative exponents. So sometimes we just have to deal with the negative exponents. A negative exponent will make your number flip over. And once it flips, the negative exponent turns positive. So x to the negative m, you're going to flip the x over, 1 over x to the m. There's an invisible 1 right here. So you flip it, and the m, the exponent, becomes positive. If your x was already in the bottom with a negative exponent, you're going to flip it back up to the top. Exponent becomes positive. If it's an entire fraction to a negative exponent, the entire fraction flips over and your exponent becomes positive. So for example, x to the negative 3 is 1 over x cubed. And don't think of it as 1 over as much as think of it as flipped. So that's why it's 1 over. And then the second one, 1 over 4 to the negative 2, I'm going to flip that 4 back up to the top. The exponent becomes positive. When it flips, the exponent becomes positive, and then that would be 16. Here is another place where I see a lot of errors. The negative 4. Yes, the 4 is negative, but it doesn't have a negative exponent. So it's just going to stay where it is. Likewise, the x. The x has a positive exponent. It will just stay where it is. But the y has a negative exponent, so it's going to flip into the bottom and go underneath the negative 4x to the 5th. So even though the 4 was negative, it does not have a negative exponent. It just stays put. For the second example, the negative exponent makes the entire fraction flip over. So that's going to be y over x squared, and then the exponent becomes positive. And now we can distribute it in, multiply exponents, y to the 3rd over x to the 6th. Okay, we're going to start doing some messy ones. Using several of our properties now. So for this problem, 3 and negative 2, there are no special exponents on either of those numbers. There are no exponents outside the parentheses. So we can just multiply 3 and negative 2, which is negative 6. You can handle this several different correct ways. And so it kind of just depends on what you see first. If you would like, you could flip the negative exponents first. The x to the negative 2 could flip into the bottom. The y to the negative 3 could flip into the bottom. Or you could apply the product rule, and just go ahead and add exponents first and then deal with your negative exponents. That's what I'm going to do, but it's not necessarily any better. So if I have x to the negative 2 times x to the first and I add my exponents, negative 2 plus 1 is negative 1. And then the y's, 1 plus negative 3 is negative 2. We generally don't leave negative exponents in our answers. Sometimes in higher levels of math we do, but generally right now, Algebra 1, Algebra 2, we don't. So we would want to flip the x and the y. I'm not going to flip the 6. The 6 does not have a negative exponent. If you are spacing out, come back right now and listen. The 6, the negative 6, does not have a negative exponent. It will stay put. And then the x and the y will flip because they did have negative exponents. But the negative 6 did not have a negative exponent. It stays where it is. Okay, for this one, there's no simplification we can really do besides flipping the letters that have negative exponents on them. So the a to the negative 2 will flip to the bottom. The c and the d will flip to the top. The b will stay where it is. The b does not have a negative exponent, so it will stay put. So the b is on the top. It will stay there. Joining it will be the c and the d. On the bottom, the a flips down. And remember, once a letter or number flips, the exponent turns back positive. The 2 and the 8. If you just saw 2 over 8, you would reduce that down. 2 over 8 reduces to 1 over 4. Look at the x's, both positive exponents, it's division. So we subtract and put it where the bigger one was. 7 minus 4 is 3. The bigger exponent was on the bottom, so my x cubed goes to the bottom. Don't try to do the subtraction if one of your exponents is negative. Go ahead and flip it first. So I've got the y cubed on the bottom. It's going to stay because it doesn't have a negative exponent. But the y to the negative 4 will flip down. And then I'm multiplying, same base with the y's, so we'll add the exponents. 1 over 4x cubed y to the 7th would be the final answer for that. This one has exponents outside of parentheses. Remember, you multiply the exponents. So that would give us 2 squared c squared d to the 8th, c to the 5th, d to the 5th. Now I'm multiplying same base with the c's and the d's. When you multiply same base, you add the exponents. I know there's a lot of rules. So 2 squared is 4, and then c, and remember if you forget the rules, here I have 2 c's, here I have 5, so that's 7 c's, and then d to the 13th when you add the exponents on the d's. Okay, I think this is the last one. 3 over 12, just normal numbers, reduce that down. 3 over 12 would reduce down to 1/4. X to the 0. Remember, anything to the 0 power equals 1. So if you want to do times 1 on the top, you can. You don't really need to. X to the 6th on the bottom, nothing else really goes with that. For the y's, the one with the negative 3 would flip, but the one with the positive 3 just stays put. You only flip if there's a negative. And then I can add the exponents on the y's, and I end up with 1 over 4 x to the 6th, y to the 6th. Okay, that's the end of the lesson. So if I can figure out how to make it stop.